In this video, I'll be demonstrating how to use Realtime GameLift to add multiplayer functionality to your Unity game. There are lots of features you can take advantage of, but I'm going to demonstrate a simple happy path use case that you can build off of. That means I didn't account for exceptional or edge case scenarios. I want to stress that this is not a production-ready project, and this demo is only to illustrate how these parts fit together. It's basically a hello world demonstration for Realtime GameLift. GameLift is a service by Amazon where you can host a backend server for your game. It comes in two flavors. One, where you can upload a custom server like a Unity server build, or two, you can use Realtime GameLift where you upload a script that acts as your backend. This is what we will focus on here and for the video tutorial. The main advantage of GameLift is that it takes away the fuss of manually managing servers. It comes with auto-scaling features and matchmaking functionality that are both easy to use. So as a game developer, you can focus more on your game code and functionality. The custom option is mostly for when your backend requirements can't be handled by a script or Node.js project. Think first-person shooter games where you would need a server build of your game running to verify what the clients are doing are valid in your game, like detecting wall collisions or whether bullets made contact with the other players. If you don't need a running copy of your game on the server and just need messaging, even high-frequency messaging, then Realtime GameLift is likely a good choice. Realtime handles all of the major lifecycle callbacks that you would expect in a game and also provides a very easy-to-use messaging system. It has support for UDP and TCP, so you have access to high-frequency messaging if needed. I know this decision can be confusing, so if you'd like to talk more about it, just drop by the Discord. For this example, I'm going to demonstrate a simple use case with GameLift queues. If you're just playing around, you don't really need queues. You can just hard code your game to a fleet and that could work. This is basically what I covered 2 years ago in my first Realtime video. But if you're planning on growing your game past the demo phase, then consider using game session queues as the mechanism for creating and finding servers to join. There are several advantages of using queues, like access to Fleet IQ for prioritizing the placement of players based on location, latency, hosting costs, and fleet characteristics. You can use spot fleets when things heat up to save money. It can also provide natural fallback servers for when things go south. It allows your game server environment to be more resilient and efficient and can be multi-region. You can also have multiple queues, like if you need to maintain different variations of your game at the same time. There's a lot of features here, so it's a good idea to read through the docs. Basically, your queue has a list of destinations. The destinations can be aliases or fleets. So the Amazon docs describes the purpose of aliases pretty well. A GameLift alias is used to abstract a fleet designation. Fleet designations tell Amazon GameLift where to search for available resources when creating new game sessions for players. By using aliases instead of specific fleet IDs, you can more easily and seamlessly switch player traffic from one fleet to another by changing the alias's target location. This is nice if, say, you have a version of the game server that needs to be retired. You can just update the alias to point to the fleet with the latest build. So in short, you make requests for destinations in a queue, and the queue will look through the list of aliases it has and return the game session that best matches the given search criteria for the player. So this is an architectural overview of the demonstration. The left side captures the Unity game client and a quick breakdown of what's needed to enable GameLift multiplayer. The API manager uses Unity web requests to send out get, post, or whatever calls you need to make to the Lambda function. The game logic is handled inside the game manager script. The real-time client code handles connecting to the server, lifecycle functionality, and sending and receiving messages from the server-side script. We have the AWS SDK drivers needed to get access to the real-time, Cognito, and SQS functionality. And finally, our SQS message processing class subscribes to receive game session fulfillment messages once they are sent out. The AWS setup includes API gateway to handle all incoming HTTP calls, meaning anything our API manager requests goes through the API gateway endpoint. Then these requests are forwarded to our Lambda function. Our Lambda function handles all of the GameLift service calls for searching, joining, and creating game sessions. Before, in my other real-time video, I had put this functionality in the Unity game using the AWS SDK, but I think this is better practice separating that logic out of the game. It's also a little more secure by having less surface area exposed for potential exploits. The GameLift realm basically consists of internal GameLift services and our real-time script. The real-time server script is our custom code we deploy to GameLift that acts as our backend server. Our Unity side real-time client communicates with this script. Messages will be sent and received between the two. Finally, we use SNS and SQS to handle the game session fulfillment notifications. These notifications are for the scenario when we didn't find a game session and one needs to be created. Our Unity client subscribes to these, and when a game and player session have been created for the player, it receives a notification with the session information so we can connect to the server. I'll be referring to this diagram throughout the tutorial video to make it easier to follow along. This diagram is an attempt to illustrate the flow of obtaining a game session in the demo and the potential paths involved. First, our Unity client makes a request to Lambda through API Gateway to search for available game sessions. The GameLift service searches through the targeted queue's destinations for a potential fleet that matches our request criteria. If one is found, return the session info back through Lambda and onto the client. Since we found a match, in the client we can immediately connect to the GameLift server using the returned connection information. If, however, we don't find a match, we kick off a game session placement request from Lambda, which returns a placement ID. Passed back to the client, we use the placement ID to subscribe to game session fulfillment notifications. Once the GameLift service finds a match, it broadcasts a notification to the SNS topic, which pushes a message onto the subscribed SQS queue. At that point, our Unity client receives the message and connects to the GameLift server with the return connection information. For both paths, we are ready to start the match. A game session has been found and server connected. The real-time client script in Unity now communicates messages back and forth with our real-time server script that's deployed to real-time GameLift. Okay, so to get started with the Lambda function, head over to the AWS Lambda console and hit Create Function. Go ahead and give it a name and hit Create Function. Next, we need to upload the demo Lambda project that I created. Start by cloning the Unity Realtime GameLift Lambda 2022 project to your computer. This has the entire Lambda project, including the UUID library that I used. So after you've got the repository downloaded, zip up all the files and folders. Next, upload it to the Lambda function. Then go to the Configuration tab and click on the role that was generated. Hit Add Inline Policy, select the GameLift service. Under Actions, check all the required GameLift permissions. You can pause the video to make sure you don't miss any. Then under Resources, input the alias name you plan on using for this setup. And the same for Game Session Queue. Put in the name of the queue you plan to use. Hit Review Policy, name it, then hit Create Policy. There's a couple variables that we still have to update, but we'll get to those later on in the code review. Then it should be ready to go. Now we're going to set up an API Gateway endpoint so that we can call this Lambda function from our Unity client. Head over to the API Gateway console and hit Create API. Use the REST API option and select Build. Name it, then hit Create API. Now under the Actions button, select Create Method and select Post. For the post setup, select Lambda function and check Use Lambda Proxy Integration. Also make sure your region is correct. Then find the Lambda function we just created and select it, hit Save. Back under Actions, select Deploy API, select New Stage, then give it a name, and hit Deploy. Now you have the invoke URL that you'll need later in the Unity project, so take note of where it's located. For deploying any changes in the future, back under Actions, select Deploy API, select the stage, and hit Deploy. So now your API gateway should be pointing to our Lambda function when a post request is made. Eventually, you'll probably want to lock down the API to only registered users. You can create a Lambda or Cognito authorizer to help with that. Check out my other videos on Cognito as I've covered at least one of these examples before. Now let's start our GameLift setup. Head over to the GameLift console and go to the Scripts section. So to get started, we have to upload our real-time server script. The script for this can be found in the Unity project's assets under the real-time server folder. I took the example one from the docs and added some customizations for this demo. Right now we're using a simple one-file script, but you can make a more complex node project and upload that, similar to how Lambda works. Find the script and zip it up. You can use the console to manually upload the script, but I like using the command line tools as it speeds up the update process. And of course, you'll need to download and configure the AWS CLI to use it. To create a new GameLift script with the CLI, you can run the following command. It's an AWS CLI command called create script. It has a name parameter, a script version, and then the path to the zip file. The command seems to require a special format when uploading the zip, so you'll have to prepend it with fileb://. After the command runs, you'll get a breakdown of the script details, which means it created successfully. Give the console a refresh and you can see our new script has been added. Next, we're going to create a new fleet. So to create the fleet, select the new script, then under Actions, hit Create Fleet from Script. Give it a name, then under Binary Type, you want to select Script. If you check out the info, it says scripts are for real-time and build is for custom servers. We want the script here. Select the script we just created from the dropdown. Leave the default free tier instance selected. Verify your region is correct. Then let's grab the name of the real-time server script and paste it into the launch path. Hit the green check mark, then hit Initialize Fleet. You can monitor all the major events in the Events tab. Let's take a look under the Scaling tab. Make sure that anytime you stop working that you set the desired instance count back to 0. Otherwise, you'll be charged a lot for that idle server. Unless you're in free tier, but still, don't waste those free hours. Okay, so it takes about 10 minutes for the fleet to fully come online, so let's get started on creating the alias. Head over to the Alias section and hit Create Alias. Name it, hit Select Fleet, and you'll see our new fleet is in the activating stage. Select it. Hit Configure Alias. Whoops, description was required. Now hit Configure Alias, and here you can see our alias is pointing to the new fleet. Head over to the GameLift Queues section, hit Create Queue, and name it. Okay, so the notification target will be important in a minute. We'll be configuring this queue to push fulfillment notifications to an SNS topic. More on that in a minute. Down under Destinations, hit Add Destination. Select your region, then select Alias, as our queue will be pointing to an alias, not directly to a fleet. Then select the alias we just created, then hit the green check mark. Then hit Create Queue. Go to the SNS console, hit Topics on the left, then hit Create Topic. There are two types of topics, first in, first out, and standard. Go ahead with the standard for this demo. Do your research when selecting the topic type for your own project, but I'm selecting standard here because message delivery order isn't needed for my demo game. Name it and hit Create Topic. After the topic is created, we need to update the access policy so that our GameLift queue can send session placement notifications to it. Let's verify with the docs that we have what we need. We have the first statement completed. Now we must add the GameLift part. Let's copy paste this template. Put in our region, account, and topic name, which is the same as the above statement. Then grab the region and account number again for the source, and then put in the GameLift queue name we created earlier. The SNS topic should now be set. Go to the SQS console and hit Create Queue. Leave standard selected as long as that still works for your game. Name it, then hit Create Queue. Once created, hit Subscribe to Amazon SNS topic, then select the topic we created in the last section, hit Save. So there's one more thing we need to do for our GameLift session placement notifications to work. Head over to the GameLift queue console, edit the GameLift queue we created earlier, copy paste the ARN for the SNS topic, then hit Submit. I like to do a quick check on the access policy to make sure it was updated correctly. Do a page refresh, and you can see the SQS send message action is now present in the policy. So I think we're good there. We need one more thing before our AWS side is complete. Head over to the Cognito section and hit Federated Identities. This is the identity pool section. Hit Create New Identity Pool and name it. Then hit Enable Access to Unauthenticated Identities. I'm doing this for the sake of getting the demo up and running quickly, as our SDK usage needs credentials to work properly. Your project may not want to give access to unauthenticated users, so you'll have to adjust accordingly. I have a couple videos on using AWS Cognito user pools as a user database and to enable sign up and login, so check those out as the concepts there can be worked into this project as needed. Hit Create Pool. Then the pool wants to create 2 new roles. For now, just hit Allow. Take note of the AWS credentials as they are needed in the Unity project. Before we're done here, we need to make a few adjustments to the role, so copy the role name and head over to the IAM console. Select roles and paste in the name into the search bar and select the unauthorized role. Then hit Create Inline Policy, select SQS for service, then select List Queues and Receive Message under Read, then check Delete Message under Write. For resources, enter in the region and the SQS queue name, hit Review Policy, name it, then hit Create Policy. At this point, most of our setup on the AWS side is now complete. So let's review the Lambda function that handles all of our GameLift actions. Before this will work for your setup, you must update the region and target GameLift queue you plan on working with. This handler is where the Lambda execution starts. Basically, this Lambda script has 2 main functions: searching for game sessions and creating game sessions. But the first thing we do is query for the queue we want to use. So using queues to find destinations, or aliases that point to fleets, is best practice, so I wanted to show that functionality here. The first thing we do is get all the game session queues. When starting out, you will probably have one queue that you plan on targeting. So in case you have multiple queues, this hard-coded name guarantees you get the details for the one you want. As your game grows, you will probably develop a more dynamic way to handle this, but the point here is to get all the destinations in our queue. Once we have our queue, I then grab the first destination, or alias, to search for available game sessions. I have this hard-coded as I know for this demo I only have one fleet running, so to make it easy, I just grab the first one. When you're ready to grow your game, you can get destinations based off other things like latency or player location and so on. For now, we just look for any active game sessions that the player can join. If a game session is found, we then manually add the player to it by creating a player session. We then return this response to the client, which contains all of the information needed to connect to the server and start the game. If none are found, then we have to create one. This is a multi-step process, so bear with me. First, we kick off a game session placement request. It contains the target queue and other parameters to find the right destination. So we're asking GameLift to create a game session with the given parameters, including the player session. But this process is asynchronous and not in a way where you can just await the response here. The response we get back is a placement object that we use that SNS SQS stuff to listen for when the placement request is fulfilled. We return that placement object back to the Unity client and subscribe to placement fulfillment notifications using the placement ID contained within the response. Then on the Unity end, once it receives that notification, it contains everything we need to connect and join the game. And to wrap up, even though there are 2 different paths with responses that get returned, I wanted to point out that I use the same model in Unity to deserialize each response just to make it easy for the demo. So in short, this Lambda function takes care of all the GameLift game session actions. Now let's take a look at the real-time server script. I based this off the example in the Amazon docs. The purpose of this script is to act as your backend server to the game. You can use a single script like this or a complete node project for more complicated setups. The script has functions for the various lifecycle callbacks that GameLift supports. For example, onProcessStarted, onProcessTerminate, onHealthCheck, onPlayerConnect, disconnect, you get the idea. There's a whole bunch and the docs will help define what they all do. And as provided by the example, there's a simple game loop function. This is like the update function in Unity. So you can perform your game state checks here, like if all the players leave, kill the game session. So let's review the major functionality. OnPlayerConnect. This is a callback for when a player connects to the server. I create an object that represents the player info and store it in an array. OnPlayerAccepted. This is a callback for when the player's session is approved for the game and ready to play. I then check to see how many active players we have. Since this is just a 2-player game, if 2 people are connected, I send out a message to everyone telling them to start the game. You can see that here with the start match message. On message. This callback function receives the messages from all the clients or players in the game. For this, I'm only sending the play card messages from the client. When it receives this message type, the server picks a random card to play for the player, stores it, and sends an acknowledgement to all the connected players with the card that was played. Our Unity client uses that message and displays the data in the UI. This is also where I call to a custom function called checkGameOver. I'm just checking to see if both players have played 2 cards. For your game, this will be whatever the game over criteria you want to have. Once it's established that everyone's played twice, I call to another custom function called determineWinner. I just add up the cards played for each player, and whoever is higher wins. Then we send out a game over message for the clients with the results of the game. For simple games, you can probably get away with a single script like this. But once you have some complexity, consider breaking this out into a node project and keeping this script with all the callbacks separate from your core game logic. The demo project for this video requires the GameLift Realtime Client SDK, some AWS SDK drivers, along with some other supporting drivers. First, let's grab the Realtime Client SDK, link in the description. Under GameLift Realtime Client SDK, click Download Now. Use the README in the download as a guide. Open GameLift Realtime Client SDK Net45. Select Release and Build. Once it's complete, go to the folder GameLift Realtime Client SDK Net45 /bin/release. Copy over all 5 DLLs into the plugins directory in the Unity project. Now let's get the AWS SDK. Use the link in the description to get the download page. Under the heading Download and Extract Zip Files, click NetStandard 2.0. Drag over Core, Cognito Identity, Security Token, and SQS into the Plugins folder. Then, if you look to the left side menu, click Unity Support. You need to get the 3 additional support drivers as well. The way I do this is open the Unity project in Visual Studio and hit Project, Manage NuGet Packages. Then search for each one independently and hit Add Package. Once you have all 3, hit the Build button. Now navigate to the Packages directory and you'll see the 3 packages. Go into each folder and grab the NetStandard 2.0 version DLL for each one and copy it over to your Plugins folder. And if you did everything right, your project should no longer have any errors. Now your project is ready to use the AWS and Realtime Client SDK. Okay, let's take a look at the code in the Unity project. The core functionality of this project is spread over 4 scripts: Game Manager, Realtime Client, SQS Message Processing, and API Manager. So I'm going to quickly review the major stuff so that you have an idea of how this all works. The Game Manager handles the main game logic and lifecycle functionality. It is linked back to the Game Manager game object in the Unity editor. That game object also has references to the SQS Message Processing and API Manager. The Realtime Client is created and managed by the Game Manager script. The onFindMatchPressed function uses the API Manager to make a request to our AWS Lambda function by hitting the API Gateway endpoint. The value set in the response tells us which path to take. Remember earlier when looking at the Lambda function, we either found a game session or we kick off a placement request? If the game session ID is present, we have a game session and can connect to it with the returned information. If the placement ID is present, then we have to subscribe to listen for game session placement fulfillment notifications. If we take a look at the subscribe to fulfillment notifications method, we await for any SQS messages. The SQS message processing function basically pulls the SQS messages with a given placement ID until one is found. When we receive our message, we deserialize it into a usable object, then delete it from the queue as it's not needed anymore. This failsafe stuff you're seeing here was something I came up with to make sure the client doesn't sit there forever waiting for a message. It's really high, like 10 minutes, but you can tune it to whatever you'd like or remove it altogether. And the last thing I'd like to point out is that you do have to set some AWS credentials to make this work. This is where you use the identity pool ID we created earlier so that the SDK can talk to the Amazon services from the client. And again, this will have to be refactored to work with however you're managing your users. Okay, so whether we found a game session right away or created a new one with the placement request, we use the end responses to get the connection info like IP port and player session ID and establish a connection to the real-time server. That is done by creating a new real-time client script and passing in the connection info. And as a side note, because the real-time client isn't a mono behavior and is created here, I decided to use event handlers to tell this game manager when major events occur. Like when a card was played, another player joined, or when the game ends. I did this in an attempt to decouple the two classes so that the real-time client doesn't really have to know about the game manager while still being able to notify it so the UI and other game states can be updated accordingly. Okay, let's take a look at the real-time client. So once the client is created, it immediately connects to the server. This onDataReceive method processes any messages received from our real-time server. As you can see, it handles all the major actions in the game's lifecycle. For example, when a game start op is received, we deserialize the message and notify the game manager so it can update the UI with player 2's info. Or when the draw card op is hit, we update the UI with what card was played. Then finally, when the game is over, we receive a message with the final results. Let's check back with the game manager. So far, we've reviewed how the major lifecycle events, like connecting to the server and how the messages are received and processed. Now let's take a quick look at how the messages are sent to the server. For example, when the user hits the draw card button, onPlay card pressed is hit, and we use the real-time client's send message function to send the messages to the server. And when the server replies with the card that it picked for the user, it comes back through the onDataReceive function we just reviewed a minute ago. So that basically wraps up the whole picture here. The rest of the code in the project is mostly boilerplate and general Unity stuff that is out of scope for this video. But if you do have any questions, please comment or drop by Discord and I'll be happy to help. Let's finish up with a quick demo. The top left is my Mac client and the bottom right is my PC. The gameplay is simple. Each player hits draw card until 2 cards are picked. Then once both players have 2 cards, the server totals them up and returns the match results. To start, both clients must hit Find Match, which generates a unique player ID and creates or joins a game session. The local player's cards always show up on the left side. Once both players are in the game session, the draw card buttons appear. Notice how quick the response is? I did not edit this down for time. This was the actual speed at which the clients were able to send and receive messages. Thanks for watching.